this is Kalpana here. In this video, we are going to solve the given differential equation which is non-exact. So let's get going. Problem. Solve x power 4 e power x minus 2mxy square into dx plus 2mx square y into dy equals to 0. Solution. Given differential equation. X power 4 e power x minus 2mx y square into dx plus 2mx square y into dy equals to 0. Consider as equation 1, which is in Mdx plus Ndy equals to 0 form, right? So here M is treated as constant. Okay, here M is a constant. Fine. The given equation, which is in Mdx plus Ndy equals to 0 form. By comparing these two, we'll get M and N. Coefficient of differential dx is your M and coefficient of differential dy is your N. Where M equals to x power 4 e power x minus 2m xy square and N equals to 2m x square y. If the partial derivative of m with respect to y is equals to partial derivative of n with respect to x, then we can say that the given differential equation is an exact equation. So now let's find the partial derivatives. This is your m and this is your m. Firstly, we'll find the partial derivative of m with respect to y. Is equals to dou y of for m x power 4 e power x minus 2mx y square is equals to, here we are doing partial derivative with respect to y, so x will be treated as constant. This is equals to partial derivative of first term with respect to y minus partial derivative of second term with respect to y is equals to, here x power 4 and e power x are constants, right? So partial derivative for constant with respect to y is 0 minus, here 2m and x are constants. So you can write this as constant into partial derivative of y square with respect to y, which is equals to minus 2mx into partial derivative of y square with respect to y is 2y is equals to minus 2 2s are 4 mxy. Therefore, partial derivative of m with respect to y is equals to minus 4mxy. Now let's find the partial derivative of n with respect to x. Partial derivative of n with respect to x equals to dou x of for n 2m x square y. Since we are doing partial derivative with respect to x, so here y will be treated as constant. Here 2m and y are constants. You can write the above as 2my, that is constant, into partial derivative of x square with respect to x is equals to 2my into partial derivative of x square with respect to x is 2x, which is equals to 2 2s are 4 mxy. Therefore, partial derivative of n with respect to x is 4mxy. Right? Therefore, see here you are having minus 4mxy and here plus 4mxy, right? From these two we can say that partial derivative of m with respect to y is not equals to partial derivative of n with respect to x. From this we can say that the given equation, that is equation 1, is non-exact. Okay. Since the given equation is non-exact and also it is non-homogeneous, you want, you can check using or by reducing the given equation to dy by dx equals to some function of x, y. If function of kx, ky equals to function of x, y, then we can say that this function is a homogeneous function and the differential equation involving homogeneous function is a homogeneous differential equation. Otherwise, it is called a non-homogeneous differential equation. Okay, if you want, you can check it. Now, and also the given equation is not in y into function of xy into dx plus x into some function of xy into dy equals to 0. Now, we need to find the suitable integrating factor in order to reduce the given equation to an exact equation. Right? So, observe m and these two partial derivatives. We are having n equals to, see, in m you are having two terms and in n you are having only one term. So, consider n equals to 2mx square y. Okay? This is equals to, if you take x common, you'll get 2mxy. Not x common. You can write this as x into 2mxy. Right? Here you are having mxy, and here also you are having mxy. Right? So, find 1 by n times partial derivative of m with respect to y minus partial derivative of n with respect to x, which is equals to 1 by, for n, x times 2mxy into partial derivative of m with respect to y is minus 4mxy minus partial derivative of n with respect to x is 4mxy, which is equals to minus 4mxy minus 4mxy is minus 8mxy by x times 2mxy, which is equals to, you can write minus 8mxy as 2mxy into 2 4s are 8, right? So, minus 4 into minus 4. See, 2 into minus 4 is minus 8mxy. You'll get the same thing. By denominator remains the same. So, here you can cancel 2mxy. Okay, simply we'll write this minus 8mxy in terms of 2mxy. Okay, in order to cancel 2mxy in the numerator and in the denominator as well. So, this is equals to minus 4yx. Since it does not contain y, right? This function does not involve any y. So, we can call it as function of x alone since it involves x. So, we can call it as function of x alone. You can name it as f of x. Okay, now the integrating factor is given by if equals to e power integral f of x into dx. What happens if we get some real number, say k, instead of function of x? Then our integrating factor will be e power integral k into dx. Okay. So now we need to find integrating factor. Integrating factor equals to e power integral f of x dx. For f of x, minus 4 by x into dx is equals to e power minus 4 into integral 1 by x dx, which is equals to e power minus 4 into, we know that integral 1 by x dx is log mod x, and you can write this as e power minus 4 log x. Since we know that m log n can be written as log n power m, then you can write minus 4 log x as log x power minus 4. Right? And also we know that since e power log some function of x is equals to function of x, f of x is nothing but some function of x, not this f of x. Okay. So e power log function of x is equals to function of x, and we know that x power minus n equals to 1 by x power n, then this can be written as 1 by x power 4, which is a required integrating factor. So now we can reduce the given equation to an exact equation by multiplying it with integrating factor. 1 by x power 4 times the given equation gives an exact equation. Plus 2mx square y dy equals to 0. Consider it as equation 2. You can write this as x power 4 e power x minus 2mxy square into dx plus 2mx square y into dy by x power 4 equals to 0. If you consider LHS part, you're having two terms in the numerator and one term in the denominator. So we can split this into two terms then. X power 4 e power x minus 2m xy square by x power 4 into dx plus 2m x square y by x power 4 into dy equals to 0. Then this becomes, in the first term you're having two terms in the numerator and one term in the denominator. So we are going to split this into two terms. X power 4 e power x by x power 4 minus 2mx y square by x power 4 into dx plus, here 1x square gets cancelled, so we'll get m 2my 2my by x square into dy equals to 0. Now cancel x power 4 and 1x here. You'll get e power x minus 2my square by x cube into dx plus 2my by x square into dy equals to 0, which is in m1 dx plus n1 dy equals to 0 form. m1 dx plus n1 dy equals to 0 form, where m1 equals to e power x minus, that is coefficient of differential dx is your m1 and coefficient of differential dy is your n1. 2my square by x cube and n1 equals to 2my by x square. Okay. If the partial derivative of m1 with respect to y is equals to partial derivative of n1 with respect to x, if the partial derivative of m1 with respect to y equals to partial derivative of n1 with respect to x, then we can say that equation 2 is an exact equation. That is, equation obtained by multiplying the given equation with integrating factor is an exact equation. So now let's find the partial derivatives. We are having m1 equals to e power x minus 2my square by x cube and m1 equals to 2my by x square. Firstly, we'll find the partial derivative of m1 with respect to y. Partial derivative of m1 with respect to y is equals to dou by dou y of for m1 e power x minus 2my square by x cube. is equals to, since we are doing partial derivative with respect to y, so here x will be treated as constant. Is equals to partial derivative of first term with respect to y minus partial derivative of second term with respect to y. Is equals to partial derivative of a constant with respect to y is 0 minus here 2m by x cube is constant, so you can write this as constant into partial derivative of y square with respect to y, which is equals to minus 2m by x cube into partial derivative of y square with respect to y is 2y, which is equals to minus 2my by x cube. Minus 2 2s are 4, right? Minus 2 into 2 is 4, so you'll get minus 4my by x cube, not minus 2my by x cube, sorry. Okay, so therefore partial derivative of m1 with respect to y is equals to minus 4my by x cube. Now we'll find the partial derivative of n1 with respect to x. Partial derivative of n1. Partial derivative of n1 with respect to x equals to dou by dou x. So for n1, 2my by x square. Since we are doing partial derivative with respect to x, so here y will be treated as constant. Is equals to here 2my is constant, so you can write this as constant into partial derivative of 1 by x square. Function of x, right? Is equals to 2my into partial derivative of, we know that 1 by x power n can be written as x power minus n. Then you can write 1 by x square as x power minus 2. Is equals to 2my into partial derivative of x power minus 2 is minus 2 into x power minus 2 minus 1. Which is equals to 2 into minus 2 is minus 4. Better, you can just simplify this. Minus 2 into x power minus 2 minus 1 is minus 3, which is equals to minus 2 2s are 4 my into x power minus 3. Since x power minus n is 1 by x power n, then you can write x power minus 3 as 1 by x cube, which is equals to minus 4my by x cube. Okay, therefore partial derivative of n1 with respect to x is minus 4my by x cube. So from this 2, we can say that the partial derivative of m1 with respect to y is equals to partial derivative of n1 with respect to x, right? Therefore, partial derivative of m1 with respect to y is equals to partial derivative of n1 with respect to x equals to minus 4my by x cube. So from this we can say that since partial derivatives of m1 and n1 are equal, so from this we can say that equation 2, that is equation obtained by multiplying the given equation with integrating factor, is exact. Now we need to find the general solution to the given equation. So the general solution of equation 2, that is an exact equation, is the general solution of the given equation. Since we know that the general solution of an exact equation, the general solution of an exact equation which is in m1 dx plus n1 dy equals to 0 form is given by integral over x m1 dx plus integral of terms of n1 free from x into dy equals to c. Now consider the first integral over x m1 dx. Integral over x m1 dx. Here we'll be integrating m1 with respect to x, treating y as constant. Okay, this is equals to integral from 1 e power x minus 2my square by x cube into dx, which is equals to integral e power x dx minus integral 2my square by x cube into dx. This is equals to integral e power x dx minus, let's write the constants outside the integral, constant into integral 1 by x cube dx. Since we know that 1 by x power n equals to x power minus n, then you can write 1 by x cube as x power minus 3. This is equals to integral e power x dx minus 2my square into integral 1 by x cube can be written as x power minus 3 into dx, which is equals to integral e power x dx is e power x minus 2my square into, we know that since integral x power n dx equals to x power n plus 1 by n plus 1 plus integral constant c for n not equals to minus 1. Since we are having n equals to minus 3, which is not equals to minus 1, so we can apply this formula here. We'll get x power minus 3 plus 1 by minus 3 plus 1, which is equals to e power x minus 2my square into x power minus 3 plus 1 is minus 2 by minus 2 is equals to e power x minus 2my square into minus, you can write this as minus 1 by 2 into x power minus 2, right? 2 gets cancelled, which is equals to e power x minus into minus plus my square into, you know that x power minus n equals to 1 by x power n, then you can write x power minus 2 as 1 by x square. Then this becomes e power x plus my square by x square. Now consider the second integral of terms of n1 free from x into dy. We are having n1 equals to 2my by x square. It involves x. So, terms of n1 free from x is 0. Integral 0 into dy is 0. Now, coming to the general solution of the given equation. Therefore, the general solution of 1 is, result obtained from the first integral is e power x plus my square by x square plus result obtained from the second integral is 0, right? Plus 0 equals to c. Then e power x plus m into y square by x square equals to c is the required general solution. Okay, so this completes the problem. Fine. So we have seen a problem from a non-exact equation in this video. Hope you'll understand. We'll see you in the next video. Until then, bye bye.